Good morning, everyone. Just going to wait a minute or two while we have a few more of the attendees check in. It looks like everybody's teeing up right now. So you'll give us 1 minute and then we'll dive into this subject. Hopefully you'll all find it interesting, if not enlightening. Sean will bring light to us all on the subject of mechanical efficiency programs and SEAL support. Certainly me, I know. All right, we're just about a critical mass from the looks of things. And all right, let's start things off. Again, good morning to everyone and thanks for joining us. My name's Chick Howsam. I'm the Director of Marketing at Swagelok, Denver. And you're joining us for the second webinar we've put on. The first one was on regulators. This one is going to cover the topic of SEAL support. And it's going to be presented by Sean Hunsaker, who is the market manager for Swagelok in the chem refining market. And he's going to tell you a little bit more about his experience, but he's got at least 15 years of fluid system expertise under his belt. Also joining us today is Cody Hildebrand, who some of you may know. He's our Swagelok regional field engineer and is master of all things fluid systems locally. A couple of housekeeping items and we'll get into it. Number one, Zoom in their infinite wisdom does not allow attendees to post video or talk during the presentation. But once we get through it, you certainly will have that opportunity. However, I'm going to point out that at the bottom of your panel, there's a chat feature. So if there's something you want to get into, just put it in the chat. If your question is more involved, there's a Q&A button down there also, and you can use that. We're going to sort of do some evaluation in real time about the questions as far as they're relating to what we're talking about. And we may just dive into those questions as we go. So if you have something of interest, don't hesitate to throw it up there and we'll get after it in a hurry. I guess there will be a poll, I should note, at the end of this thing that I'll launch. And it's merely a question and answer about what other topics you'd like to see us address. So it helps us refine what topics we can get into going forward with this technology in our brave new virtual world. And sort of last but not least, a legal stipulation here. We are Swagelok Denver, and we're only able to support customers in our Colorado and Wyoming marketing area. If you're in that area, reach out to us. We'll do everything we can to help you out. If you're outside of that area, we will happily point you in the direction of the Swagelok distributor who supports your region. We just like to keep everybody playing nicely in our particular sandboxes. So that's how that goes. With that, I'm going to hand it over to Sean. And Sean's going to take you through our discussion, tell you a little bit about who he is first, and we'll get into it. Sean, over to you, buddy.
Thanks, Chick. As Chick mentioned, Sean Hunsaker here. I'm coming to you from the Cleveland area of Ohio, where Swagelok Corporate has its headquarters in our manufacturing facilities. As he mentioned, this is my 16th year with Swagelok. My current position is a market manager for chem and refining, but really my focus is on working with our customers in rotating equipment departments, as well as then the large OEMs that manufacture the rotating equipment, the pump companies, compressor manufacturers, et cetera. It is a global responsibility. So pre-COVID, I spent about 50% of my time. I've been in plants around the world in Asia, Europe, Africa as well, and certainly throughout North America. So what I prepared today is some of the pictures of things I've seen in the field as our customers are working with us to improve SEAL support systems. So with that, I think we'll get started. So the agenda for today, I'll cover just a little bit of the history of API 682 and what I think from reading and going through that, what the major objectives are, give you some examples of piping or tubing, the choices that you need to make there. Certainly both are viable for SEAL support systems. And then I really kind of want to get deep on two things that really hit me throughout the standard is designing these systems for reliability and for safety. Those are key themes of the standard that pop out quite frequently. So I think that's what we'll spend most of our time talking about today. Certainly, as Chick mentioned, if you guys have questions during this, you know, Cody and Chick are going to monitor the Q&A and the chat feature, and certainly I'd appreciate if I'm on a topic and you want to ask something, they'll interrupt me, and then maybe while I'm on that particular point, we can address it. Anything following further, you know, more additional follow-up, happy to do a call with you guys or anybody on this personally afterwards. We can schedule that. So, all right. Just a little history on API 682. The first edition was in 1994. You know, I just want to mention that, you know, the nature of these standards are, they aren't the leading edge. It is the tried and the true. It's everything that's come out and been tested in the field for several years, and then it makes it into that publication when they, you know, go through that review process. So about every 5 years, with sometimes some delays in there, they're publishing a new version of these standards. And typically, like a good example of this is kind of in that second edition, 2001. Well, gas seals for pumps were out there for quite some time, as well as dual seals, but they really didn't make it into the standard until 2001. So it does lag a little bit behind what some people in the industry are doing, but it is an excellent resource, as it's definitely something that's been out in the field, proven to work, and wherever there are issues with it, they do note that in the standard. So the focus of today is going to be the fourth edition of API 682, published in 2014. I think it's important to first note that it's a standard for sharing of best practices. It's not a code like ASME B31.3. So I think, you know, as a designer of systems, and when we get involved with this, it's a great reference, but there are times when you might need to deviate. So throughout the standard itself, it's, you know, language like unless otherwise specified is very prevalent. It's really the gold standard. It is, you know, requires the highest level of quality components, et cetera. So when we have customers in the chemical industry that may have a split between ANSI and API systems, or even chemical plants that are completely ANSI, API 682 is often referenced because it is that gold standard. And then they might just back down on some of the component requirements because it's not a petroleum service. The two major sections for seal support systems that I look at are Section 8 and Annex G. So those are the ones that I reference the most. You know, Swagelok does not make a mechanical seal. We are not pump manufacturers. You know, there are the you know, Eagle Bergmans of the world, Flowserves, John Crane. Those are your seal guys. For questions about seals, still continue to work with them. Where we come into this is being fluid system experts. Swagelok's been designing and building fluid systems for a long time, and over the last 15, 20 years, we've really become quite involved with seal support systems. And throughout this, what I'll talk about is really designing for the reliability, safety, and ease of maintenance on these seal support systems. We're working with customers right now that believe that somewhere between 50 and 60% of their seal failures are the result of something going wrong with the seal support system, loss of flush fluid, or somebody didn't turn on the gas to the seal. And while it may not cause a failure that day when they commission the pump, it dramatically reduces the life of the seal. So we really want to make sure and take care when we're designing seal support systems that we design them for reliability, safety, and that ease of maintenance. So piping or tubing, what do we choose? You know, in the past, for years, piping was the preferred choice. And whenever we look at the standard right now, everything's referred to as a piping plan 53 or piping plan 52. But I wanted to show an article here from Heinz Block, he's basically like the Yoda of rotating equipment. He publishes tons of articles in hydrocarbon processing. He's an advocate for the use of tubing in these systems, and we've seen that from the major manufacturers of seals and pumps over the last 20 years, that tubing really has become a much more predominant connection type in these systems for a variety of reasons that we will discuss. I pulled these two tables directly from the 4th edition API 682 because over the previous few editions, there were some inconsistencies in these tables. They didn't list things correctly. So right now it's been all corrected. It's good. You have an equal choice between pipe or tubing. Pipe covers you from 1/2 inch to 4 inch, and there's all your schedules of piping to use. And the tubing is from 1/2 inch to 1 inch. I think you should note that below 1/2 inch, you can see there's really no recommendation. And really for gas seal plans like 72s and 74s, just work with your local Swagelok sales and service center to specify the appropriate tubing wall thickness for that. Typically, the pressures are not really a concern. It's, really low pressure nitrogen. We also see usage in these systems of tubing above 1 inch, particularly at the OEM level. So companies like Siemens and Dresser-Rand are starting to use tubing above 1 inch up to 2 inch on these systems. But I think for the most of your guys' applications in that refining or chemical processing world, 1/2 to 1 inch tubing is really going to cover you. But I did want to mention, I'm going to highlight something right here. That is the wall thickness, the minimum wall thickness. This minimum wall thickness for a 1/2 inch tube, it's going to give you a burst pressure at 0.65 around 20,000 PSI, working pressure in that 5,000 to 6,000 PSI for a lot of these wall thicknesses. That's far and above what almost all of these systems will ever see, and it's really above what we would often provide to people using 1/2 inch through 1 inch tubing. But this is the API recommendation because they want a rigid, robust system. If you think about your maintenance techs working on pumps, going around pumps, even though it's not recommended and they're not supposed to do it, use it as a foothold, place to put their foot or a hand. They want that little bit more rigid tubing, even though the working and burst pressures are far above what you might need. I use this time to bring this up because I have seen in rotating equipment departments, because when they started to use tubing, they just pulled their instrumentation spec over into the rotating equipment group, and they were using, thinner wall tubing on API applications. So just a good double check, make sure your guys in the field are running that heavier wall tubing, and that's something that our sales and service centers stock for you guys as well. So here's a good example, piping versus tubing. This is a large pipeline pump, and this is a bearing lubrication and seal flush system. You can see it's built completely out of threaded pipe. So this is as it comes from the OEM and was installed at the pump station there. And one of the big service items on this pump indicated through the red arrow there is that box coming off the side is the bearing housing on here. And the company that owned the pipeline here was having some serious maintenance issues with that. Every time they had to access that bearing housing and pull that back to get into the bearings, they had to disassemble all of this pipe work. And they estimated that it took, a team of guys about 40 man hours to disassemble all that, pull that cover back and get into the bearing. So it was a big cost on the maintenance side for them. As well as if you look at the system right away, you can see I've got a ton of potential leak points there. And if you think about pipelines, having a leak at a pipeline station that's lightly manned, that might be basically some GPS coordinates, not a good thing to have a guy get in the car and go 2 hours out here to fix a leak on the system while they're standing in a puddle of jet fuel or gasoline or something like that, trying to figure out, well, where is this leak coming from and how do I take apart this system? Another thing you can note, it's all done in carbon steel piping. So it had to be painted. So when they would rebuild this system, what they had to do about every 10 years or so anyway, the guys would have to thread all this stuff together, and then another contractor would have to come in to paint everything. So we're looking to improve issues with corrosion and reduce the costs on painting. They also noted, hey, I got a kind of torturous flow path here. There's a lot of hard 90s and just not an apparent what this system is doing when you walk up to it. There's also a filter in the middle of this system, which is difficult to access. So there was a maintenance issue on the system itself when they had to change filters. So overall, I think they were looking for a better solution when they had to work on the bearings or rebuild these systems in general. And they were thinking, gosh, we've got a lot of vibration on these pumps, and this pipe work is quite heavy. So it sits off to the side of the pump and actually over time really just shakes itself to pieces. So really just stepping back and saying, okay, we're trying to solve a maintenance issue here and a time, a cost issue and a reliability issue. And so they looked at tubing as a potential solution for this problem. This is the exact same pump, but with tubing installed instead of the piping. So the first thing I see right away is just what a massive difference on the cleanliness of the installation, right? So number one, first thing I did was I was able to go from 1-inch pipe because my flows improved with bending, now down to 3/4 and 1-inch tubing. So I got improved flow out of it. I got a material upgrade. I'm no longer using carbon steel. I've now got stainless steel, so I don't even have to paint it. Right, my access to my bearing housing, the problem we were originally trying to solve, is a lot easier. I just loosen a couple fittings, swing those candy canes out, and I can pull that housing on the bearings and access it. My serviceable components, like my filter, very easy to see where my filter is. I've got a block and bypass if I need to change that filter. So, several advantages gained by going from a threaded pipe system to a tubing system like this. One of the other things that was improved that we worked with the engineering team on was the vibration issue. Now, these pumps are large, they vibrate quite frequently. The whole pipe system, suffered from that. The vibration studies on this pump showed that if you hug the tubing around the center line of the pump where vibration is lowest and support it well enough, that whole system now vibrates with the pump instead of separately sitting off to the side on that pad like that pipe system. So overall, the improvements were quite dramatic for the pipeline company, and they've implemented this across the pipeline because where they were doing maybe 1 or 2 pumps a week, they can now do about 5 or 6 pumps a week when they retrofit these systems and replace them with tubing. And they're really able to accomplish that because those pumps right there, they're using that same model across several sites throughout the pipeline. So we were able to do measurements and create templates and do pre-assembly of fittings and pre-bending. So the system arrives, we know what model pump it is, and it's already pre-bended. It kind of goes together like Legos. So a lot of that time savings was also a result of a close collaboration on how much work can we do off-site, because on-site time by these guys was quite expensive for the owner company. Okay, so let's get into a little bit of designing for reliability. And, I made reference to this before, but Annex G is my source. Whenever somebody says, what's a Plan 12, what's a Plan 23, I've been doing this long enough now that I know most of them, but I still always pull out my guide and go to the back where my ISO diagram, which you see on the right there, is. And I want to make an important note here that, like I said, the standard kind of is a laggard to what people are doing in the field, but they still want to give people pertinent, relevant information of what's being done. What they've done to accommodate that is wherever something has not been proven to have a 3-year successful life, they note that in the notes beneath the drawing and call out for each plan. So that's something that you should consider when you're designing plans and looking through the book. Not all piping plans are created equal. All right, so for this one, the Plan 12 has not demonstrated a 3-year successful operating life, and that's primarily because there's a strainer in this plan. It can be a reliability concern, because if I'm not doing my preventive maintenance and blowing down that strainer, it can clog, I can lose my flush fluid, and then I've got a seal issue. So it's important to use Annex G just to make sure that I'm understanding the pros and cons of each installation. I mean, we have customers that will put that strainer in there for a period of time, and if they demonstrate that that strainer is never clogging, it's never getting any grit in it, they remove that component and basically make it a Plan 11 then, just to remove any possibility of an issue. One of the big things that all rotating equipment engineers I talked to, I showed you that picture of the pipe system with threads on it, is really trying to get away from threaded connections. And that's throughout the 4th edition of API. There's always mentioning get rid of, as many connections as possible, because every single connection on a seal support system is a potential leak point. However, as I said before, this is a recommendation of best practices. Sometimes you might need to add additional instrumentation. So I think there's a tension for designers when they're looking at seal support systems. They see API and they say, well, this is the way API says I have to do it. But as you know, an owner of this piece of equipment, I think you should also consider there may be times when I need to add something for a period of time to get diagnostic information. So I'll pull up a quick picture here of a modified Plan 12. So I still got my strainer and my orifice in there, but in this instance, now I've added 2 gauges on either side of the strainer, right? So we've had customers that have had issues with strainers cloggings, maybe, you know, and they don't know the frequency. So it's within your purview then to add something like gauges to monitor that strainer and maybe devise a new preventative maintenance schedule after you've had them in for a little bit. It's not that you have to leave those gauges in there forever. You know, once you come up with a new preventative maintenance schedule and say, okay, that strainer is clogging every 3 months, we're going to PM it every 2 months, you can take the gauges out then and return it to the basic Plan 12. And I think that's where tubing can give you a little bit of flexibility to easily make those changes and add and remove instrumentation. So, you know, I don't look at API as my Bible, but it's a heck of a good place to start and then make informed judgments from there. So I'm going to give you a couple pictures of installs I see and some of the challenges that guys have in rotating equipment. This is a new installation in the fracking fields of southeastern Ohio, where they're fracking and taking natural gas liquids and natural gas out of the ground. And so here's a series of pumps, and you know, there's a couple of things I noticed right away. Right, here's my orifice plate on a basic Plan 11. It's a Plan 11 with the 52 on there as well. That's the seal pot that you're seeing. Well, they did have some clogging issues on these orifices when they started up the plant. The gas coming out of the field, it's got liquids, it might have some other stuff in it. But if you can see, as this Plan 11 is oriented, not really an easy way for them to add that gauge to figure out, you know, is it clogging, maybe moving that orifice into the middle there and putting gauges on either side of it just to see, am I getting clogging issues, possibly putting a strainer in there for a period of time. And again, I think that's where, you know, you can play with the orientation, the components on these things to diagnose problems. Once you got to figure it out, you know, revert it back to that Plan 11 and just have the appropriate PM in there. Next thing I'm looking at is 1, 2, 3, maybe 4 connections going into my seal there from that Plan 52. Too many leak points. It's too close to the pump. It's just a reliability issue. And so there really isn't a lot of need for us to ever use 3 or 4 fittings to get out of a pump and into the seal pot. And it's just something we should not be doing. And I'm sure the one thing that everybody knows right away, my hose. Hoses really aren't a recommended thing for API service. I would always tell customers, and it's really not, hoses really aren't even referenced in the standard at all, is to always go with tubing wherever possible, because hoses are not permanent installations. They will fail. I can't tell you when this hose will fail. I can just tell you by looking at it right now, it will fail someday. Maybe it's going to be Christmas Eve or your daughter's birthday. I don't know. Just hoses aren't permanent installations. Let's just not go with something like this. I won't even comment on the, you know, the hose laying on top of the pump or the twisty ties used to hold it up to the gauge in the background there or anything like that. Just, you know, while it might be acceptable for an ANSI service, I would just never recommend the use of a hose in API service. All right, there are fittings and things out there that we make and that we've developed to specifically address some of these issues. So on the left there, you see an extended male connector. It's a long male connector to get away from the seal chamber, to not have to use 3 or 4 fittings to get outside that shroud on that pump and connect to your tubing. So we have like a full hex version of that. And then on the right, you can see, or in the middle there, there's a picture of a tight clearance area where maybe that full hex version of the fitting wouldn't have fit. We make a machine shank to fit into, you know, Sundyne pumps or vertical pumps like that. Sometimes have those recessed ports in the housing where you might want to use that machine shank version. And you can see by using just one of those fittings, I've eliminated 2 potential leak points on that installation. And this is a key consideration too when you're talking to your installers, is make sure they have the right components even when they're doing simple flush plans. It's just too easy for them to say, I got to go from 1/2-inch MPT to 3/4-inch tubing. I don't have that in a single fitting, but I've got 3 or 4 of them that I can make it in my little cart. You're just adding leak points when you do that. So they have the right components and the right understanding that leak points are a potential issue for reliability, then we should get nice clean installs like you see on the left. Eliminating leak points, I look at temperature measurement quite a bit as well, because I've seen some monstrosities put together to to add gauges into these systems, or excuse me, thermometers into these systems. Here's one that's not actually too bulky, but they've gone from 1/2-inch tubing sized up to looks like maybe 1-inch pipe to fit the thermal well and the thermometer in there. But that's a costly assembly right there for somebody to manufacture, just to put in a thermometer. They've got 1, 2, 3, 4, 5 welds on that. That could be somebody's whole morning making something like this. But for me, the bigger concern is I'm looking at that threaded thermal well in the system right there. If somebody has to change that thermometer because it's failed, and they go out there and they accidentally unthread that thermal well, then I've got an uncontrolled release of process fluid. My flush fluid's going to just go right all over my installer right there. So several things here that could be improved, and you can see here a easy way to add temperature measurement is through a fitting called a thermal well T and a short stem thermometer into the system. The 52 picture on the right has them going to and from the seal into the pot. That is not something that's indicated on API, but it's easy to install with this fitting. So I think there are solutions out there if you're looking to add instrumentation or reduce connections, and we're happy to work with you on those solutions. Okay, getting back into the standard, designing for reliability, let's talk about what you should be doing with instrumentation in general. A nice thing now is all instruments are recommended to have block and bleed valves on them. While that sounds like a no-brainer, I see many, many pumps installations where they have process gauges into a line without any way to isolate that gauge and replace it when it fails. So you have failed gauges sitting there on suction or a discharge or a seal system, and they failed, and now basically if I have any issues with that pump, I'm blind to what's happening in that pump. So here you can see a between bearing pump on that little picture on the right. You've got orifices in those in the bigger fittings on the bottom with little block and bleed gauges leading to my process gauge. So just remember that I got to take into consideration, how are my people going to maintain this system? Sure, everything works when I put it in the first time. Well, it should, but 5 years from now, something's going to happen. How are they going to get out there and quickly change out a gauge or a transmitter or a strainer? Any of these components, just they need to be accessible and easily visible. Transmitters are the definitely preferred way to go for the 4th edition. It's recommended that everything is a transmitter. In fact, they default to that. They talk about saying if you can deviate and go to a switch. So on the right there, you see a transmitter. I mean, this is the future, the holy grail for seal companies and owner companies is to use this information to actually do predictive maintenance, to actually know, hey, I've got this much time left on my seal based on what I'm reading in my transmitters, the feedback I'm getting from my seal support system. I don't think everybody's quite there yet. The common thing I hear is that, I've got a ton of information. I don't have the systems right now to be predictive yet, but hopefully I think we're working towards that. So on that right, you see the transmitter there. We're on a gas plan like a 74 where you're putting nitrogen in the seal. You want to just see what my pressure, my flow is through that to the seal. On the left, we're seeing a plan 76 right there with a switch on it, and that's fine too. I mean, maybe sometimes it's only necessary to have a high level, a low pressure alarm, a high level alarm, something like that, that gives you just a basic signal. But again, I want to look at too, how accessible and easy to change is this stuff, right? On the right there, everything's rack mounted on the front. If I need to change my gauge out, I can easily get it off. On the left picture there, I see a threaded gauge into a valve. I'm not sure how I would be able to really change that gauge if I needed to without taking that entire system offline and taking everything off of that panel. So just think about positioning commonly serviced items in a way that I can easily access them, and using technology like a tube stub on the bottom of a gauge to go into a fitting so that I can just loosen that fitting and pull the gauge out and put a new one in. So even small considerations like that can help increase reliability. All right, additional reliability concerns, vents and drains. You know, those are critical to include on many, many systems. This one that I'm showing here on the right is the 53B. The accumulators on the back side of my line drawing there, and you can see the lines coming to and from the seal going through that cooler. You know, and while the focus of the 4th edition and the Annex G is on the components actually sitting on that stand, something that absolutely needs to be considered is, how are my guys going to hook this up when they're in the field? Do they have a drawing? Do they have a design that shows them that they need to put in those high point vents or those low point drains, or that I do want some temperature monitoring on my to and from the seal lines? If we're just leaving it up to installers and saying, hey, here's a stand with the accumulator and cooler on it, run the lines to and from the seal, we're leaving it open for their interpretation. I've seen plenty of Plan 52s installed where the inlet and the outlet to the seal has been switched, and it's running backwards. And so providing the installers with a drawing and the right components to put that in there really makes a lot of sense. If you eliminate the high point vents from this, you can get a slug of air in your seal, run it dry. You can get some air stuck in your cooler and reduce the efficacy of your cooler. So I really urge everybody to consider, when I have to have my high points and vents and drains on a system, provide an engineer drawing, a picture, and a box of components, or as much as you can give them to make it installed right. Because that first time you start it up, if it's backwards or the air is not bled out of it, you're really going to impact your seal life. So installation is a big reason that we get some problems with seals, is when it's done incorrectly. All right, designing for safety. So reliability, next big thing, you know, certainly two major considerations, reliability and safety. One of the main focuses of the 4th edition is to make sure that when we do seal support systems, that everything's located in a range to be easily visible and worked on by the operators. So the picture on the right there is an actual image of a Plan 32 as I saw installed in a refinery. So you can see, I'll diagram this out for you. Plan 32 provides an external flush into the seal. So my flow came down this hose, which I would typically not want to hose in this situation. It's got to do a hard bend up in 180 degrees there and go into my headland flow indicator, up through my strainer, another hard 90 through my rusty check valve, and then I have a half-cocked ball valve as my flow control. All right. So while this may technically function as a Plan 32, I don't have pressure indication, I don't have temperature indication, and you know, what is the real chance that my operator doing their rounds is going to get down on their hands and knees and look at that headland and make sure I'm getting appropriate flow? What about if I have a turnaround and I got, you know, 200-300 contractors on site, somebody walks up to this, surely that ball valve isn't supposed to be half open, it should be full open or full closed. Well, you know, a ball valve shouldn't be used for full control. That should be a needle valve, and certainly just leaving it ambiguous like this can lead to catastrophic failure, where somebody closes that and you lose flush, or fully opens it and you harm the seal. So I think a solution to that, you know, even though if you look at the ISO diagram at the bottom of the screen, what you're seeing is just components hanging off a piece of pipe or tubing, you know, it's a much better solution to use panels. And I'm a big advocate of using panels for any of these systems that we can. I know systems like a 22 or a 23 is often just a cooler and lines running to a lot of flush plans are not really conducive to a panel. But is there a space near that pump where we can put some type of information on a panel or on a placard or something like that, because making all this stuff apparent to operators and maintenance technicians that these are systems and this is how they operate increases safety and increases reliability. So now this is my 32. I've got, real clear indication of my flow. I got a high quality flow meter on there. I can see my temperature. I can see my pressure. It's pretty, apparent where the flow is going to the seal from the flush source. It looks like a system. The other picture from before, who knows what that was, right? So big advocate of using panels or displaying information on or near the pump about what this system does and where or where not I should be looking for my flow, pressure, and temperature indicators. This is one of my favorite examples of using a panel. Does this work? The black magic marker, the Sharpie on the panel. This is a Plan 74. You can see the guy wrote on there, 55 pounds for my pressure, do not adjust. And then next to that top flow indicator, they've got, at 5 FCH, write the maintenance order. Then at 10, they will change the seal. Okay, so yes, it's better than nothing that they've done this and written this on the panel, but how do we take this to an extra step? How do we make it safer and more reliable? How do we kind of, make this part of the panel? And there are solutions out there to do that. Really, the technology today and the availability to do things like a vinyl wrap on the back of the panel. It's amazing the type of information and things you can include on there. The options are really limitless. These are the vinyl wraps that you see on cars when it looks like a very fancy paint job with decals and all that stuff. It's the same type of vinyl. It will not fade in the sun. We've done salt spray testing on it. If it gets a little dirty, all you have to do is wipe it off. But then what you can do is put whatever information you want on the back of that panel. So for this one, it's a 7276. So we have two different systems there. This is a gas nitrogen to the seal and then leakage collection on the 76 side. So right away I have a color change denoting that I've got two different systems. It also tells me that I've got two different materials there. The 72 clean dry nitrogen, I can go with stainless steel. On an ISO stripper, I could get some acids back on my flare gas, my leakage collection to send to flare, so they want that in Monel. So reliability, safety right away. Coming up to the panel, the guy can see two different systems, two different materials. Good. What else can we put on the panel? How about at the instrument, the pressure gauge, we see nitrogen in the seal should be 2 to 3 PSI. We also have that same information at the regulator as well. So, just as much information as you can put on there. We have new people entering the industry, new engineers graduating college that don't have the 20, 30 years in the field like some of you guys do. How do we make it easier for a new person to walk up to this, somebody that's not, a veteran, and understand how to operate the system or when not to touch it? All right, what about commissioning and operating instructions? I've got bypass valves labeled, I've got flow control valves labeled, and then I'm saying that right here, gas to the seal should be first on, last off, prior to lining up the pump or after it's blocked in and drained. Like I said previously, seal failures or premature seal failure often occurs because of improper seal support system delivering either flush fluid or the gas. And if we don't have good commissioning instructions located on or near the pump, you may not fail the seal on startup, but instead of getting 5 to 6 years out of that seal, or 10, maybe now you're only getting 2 or 3. And you may not even know that you've damaged it until later because somebody commissioned the pump improperly. So as much information as we can put on panels, placards, whatever around the pump, I think that's always good. There's a surprising lack of information that I see on many pump systems when I go out in the field. I visited some customers that are starting to put information cards, placards, commissioning instructions on, and it really does help improve safety for the guys out there working on it and the reliability of the system. All right, one thing I did want to bring up that's an improvement on the 4th edition from API 682 is they no longer want seal pots filled by standing on a ladder. They want everything filled from grade. So I'll indicate here with a little bit of an arrow on the ways that this was filled before. It was an unsafe and inefficient way to fill these seal pots. You can see up at the top of that seal pot was a pipe plug. So an installer would have to get a ladder, probably had to have either fall protection or a buddy there to hold that ladder while they're climbing up to the top, unthreading that pipe plug on top of that seal pot. They may have had to shut down or cool down the equipment before doing it if it was extremely hot service. When they did take that pipe plug off, they had health and safety issues because they were exposed to whatever's in that pot. And on the Plan 52, normal leakage from the seal goes into that pot, and if it's gaseous, it kind of bubbles up through. So just by taking off that plug, you're exposed to maybe process vapors as well. And sometimes that was, it could be pressurized if you had some really bad failures within your seal pot system, or if it was a pressurized system, or it could be very hot. So, not an efficient or safe way to fill these pots by climbing up on a ladder and then using a bucket or a little pump to put it into the top. There's better ways to do it. So that company, what they decided to do is start in this different area of the plant, but retrofit all their seal pots with a single design for filling from grade. So they tee into the top of the pot with a tubing array coming down to a series of valves that's 1 meter or 3 feet off the ground, so that now my installer is able to take a cart, wheel it up to the bottom, hook into that, and hand pump it up through the tubing into the top of the pot. No longer do you need to take the pot offline or the equipment offline, let it cool down or anything like that. I can refill while it's in service. Safe operations, no ladders needed. The gauge on this assembly right here indicates if there was a failure at the check valve at the top or anything like that, and there would be pressure in the line, then the guy knows, hey, I can't refill this now. I got to wait till the equipment can be shut down. There was a failure at the check valve or something's wrong in the system. So there's also safety built into this. So no exposure to vapors. I'm not tapping in the system at any time where I'm going to have exposure to those vapors. So this was part of a standardization process that this refinery went through. And the refinery was able to do this, install this same assembly over a period of time across all their seal pots. So from a safety standpoint, no more ladders for sure. But then from a reliability standpoint, they started that process of standardization. And by the time they were complete, they only had to train their mechanics and operators on one way to fill seal pots throughout the entire facility. Even though they had, multitude of providers of seal pots and seal systems, different manufacturers, the way to fill them all was the same. So when we talk about standardization, I think it's a big topic, and it can seem insurmountable, but breaking off little pieces and saying, okay, so maybe I can't replace all my seal pots with the same manufacturer seal pot, but maybe I can change and make sure they're all filled the same way. So now that's a standard design that we incorporate onto all seal pots that we provide, is that filling arm, that safe fill system to fill from grade. So I think I'm about at a half hour talking here. So I want to just wrap up and say, I think that tubing does offer some advantages for seal support system. I think it's overall lower costs, flexible in adding or subtracting instrumentation as needed, but really always make sure that we're designing for reliability and safety. Let's reduce leak points wherever we can, use panels or information posting stations around the pump to enhance reliability, and simplify that operation or maintenance for everybody, because the more steps they have to go through to change something or operate or maintain the system, the less likely the average person is to do the proper maintenance. Safety is such a big issue. Seal pots are an easy place to start and comply with that fill from grade recommendation in API 682 4th edition. And certainly standardization pays dividends, maybe not the first time, but as you work through that process, it's a big improvement for safety and reliability. So with that, I'll take any questions. Anybody have any questions?
I don't know about it. I'm not really equipped to ask this question, but I'm going to comment on it. You had mentioned earlier about a lot of people not being 30-year veterans anymore. Are you seeing more and more of that, the need to almost to make this stuff idiot-proof because of the lack of experience that we're seeing in the staffing in these organizations?
Chick, I think that's part of the tension within the standard. We really want to always make these systems as idiot proof as you say, or as robust and with the need as little intervention as possible. And that's why I say, if you need to add additional instrumentation where it's not shown in API, it might be good to add it for a period of time and then remove it so that you're removing those potential leak points. Once you kind of solved or diagnosed that problem, and the loss of our veterans, our 20, 30-year guys, is a problem in all levels of this type of industry. I don't think it's unique to rotating equipment. But yes, I think in general, anytime we can just make it safe, I think the bigger concern than even the rotating equipment departments is the contractors coming on site. There really is not a lot of control for an engineer to know, is the guy going to be doing this project? Did he start yesterday, or is he been doing this for 10 years? So anything we can do to give them more information, or even just say, if it's on a panel, it looks like somebody spent some money on it. Maybe the guy who was going to just play with that valve chooses not to because it looks like a system and it looks like it performs a function. When it's just a valve hanging off a piece of pipe, not a lot to tell me whether I need to actuate that or not.
Got it.
Hey, so we got a question from somebody that says, is this presentation available offline to customers or staff?
Yeah.
Yeah, it will be. Sorry, Sean. You'll be getting an email. All the attendees will get an email with a link, and this will be being recorded and will be on our Swagelok Denver YouTube channel, and you'll have that link and be able to get right to it.
Any additional questions from anybody? Well, if there are any follow-up questions or any more interaction requests, please reach out to Cody or Charles here in Swagelok Denver. And if you want to follow up with a conversation with myself, I'm always open to do that. And certainly guys like Cody are very versed in this application as well, and they're your local experts. So
Hey, Sean,
yeah, go ahead.
We got a question where somebody said, can Swagelok help with the design?
Yeah, absolutely. So we have standard designs for all. I think there's about 30 of the API designs. So we have a catalog of all the designs on there. Where we kind of say is the user's responsibility is you guys select the seal. And that should dictate the type of system. And then what we're going to do is talk to you once it's chosen, so that seal will say we need a plan 52, where we'll talk about design is, and how do you want that 52 to look? Where is it going to be positioned? Is it a left-hand, right-hand pump? What are the other site considerations? What are your maintenance guys' considerations, et cetera? And that's where we'll do the design. But as long as you're telling us, hey, this is the type of system, the seal support system basic plan I need, we can go from there.
All right. Before we run, and we're going to run.
Oh,
out of time.
I got one more up there. I saw check.
Okay.
Yep. Yeah, and plan 54s are something that we do design as well.
And the question was, can Swagelok design complete plan 54 systems?
Sure. Absolutely. So currently, most of those we're doing here in Ohio, and so we typically just set up a conference call with you locally with our tech center here in Ohio, and then that is a coordination between Swagelok Denver and corporate to come up with the design. It can be built either here in Ohio or at Swagelok Denver, but we do want to have that conversation with you guys because 54 is just they're a little bit more complicated, and we want to make sure we're doing the right thing.
All right. While you guys are considering any other questions you might have, I'm going to launch this poll I had threatened. All it's doing is asking what other topics you'd like to see us address. So take a minute and give us a vote, okay? Sean, what's going forward? Is there going to be another update on you say it was every 4 or 5 years for API, but do the ANSI issues change more frequently than that?
No, so ANSI and API stopped, excuse me, API and ISO stopped collaborating. Really, ANSI just takes what API does, and like, so a plan 32 for API would be a 7532 in ANSI. You know, and then, like I said, they may just slightly downgrade some of the requirements for the components for ANSI pumps. API is scheduled to, last I had heard, come out with a new edition in 2021, but that was before, obviously, the whole situation. So who knows?
Right.
You know.
All right. Okay. It looks like the leader in the clubhouse on our next topics are going to be valve selection, analytical instrumentation, and sampling system best practices. So great guidance, guys. I really appreciate it. We can get something going on all of these topics, and hopefully we'll have somebody like Sean, as skilled and knowledgeable as he is, to help present on these topics. Last call for questions, folks. Otherwise, I want to thank you for your time. Sean, thank you for your insights and the benefit of all your experience. If you need us, you know where to find us at Denver Swagelok, Cody, myself, etc., and all your account managers are all available to address these issues whenever and wherever they come up. Any last thoughts, folks?
Thanks, everybody. Really appreciate it for having me here.
Thank you, Sean. Thank you, Cody. Talk later, guys.
All right.
Yeah.